Okay, welcome to our today's class. In this session again we are still in geometric progression. So what type of geometric progression is convergent? So we'll see this. So before doing this, don't forget to subscribe to our channel, strike the link button to get the new notification. So note, let G1, G2, G3 blah 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 be the geometric progression with common ratio R. So if absolute value of R is less than 1, that is, if minus 1 less than R less than 1, what is going to happen for the sum? Sn. Sn is simply G1, 1 minus R to the power of n over 1 minus R. This, whenever you decompose it, we get G1 minus G1 R to the power of n, 1 minus R. This is equal to G1 over 1 minus R minus G1 R to the power of n over 1 minus R. So, as n goes to infinity, what happens for R to the power of n, where R is an element of minus 1 up to 1? If R is an element of this one, what's going to happen for this one, for R? For example, as an example, take simply to make it palatable, okay, so that it enters without any problem. Let R be 1 over 2. Take any number as an example in between this one and this one. So, R equal to 1 over 2. R to the power of n is how much? 1 over 2 to the power of n. So, as n goes to infinity, what happens? R to the power of n, which is 1 over 2 to the power of n, goes to what? As n gets larger and larger, the value of n remains the same, but 2 is getting bigger and bigger. Therefore, whenever we divide 1 with very big number, R to the power of n, or 1 over 2 to the power of n, goes to 0. Therefore, this thing disappears. Hence, S, we call it the infinite sum. S infinity. This is G1, 1 minus R minus G1, 1 minus R times R to the power of n. As n goes to infinity, therefore, R to the power of n again goes to 0. Hence, this is G1 over 1 minus R. This is where absolute value of R is less than 1. Absolute value of R is less than 1. Therefore, we call it, such type of geometric progression is known as convergent geometric progression. Let us see one example. Find the sum to infinity of the geometric progression 1 over 5, 1 over 25, 1 over 125, and so on and so forth. So, as a solution, what we are going to do is the following. We are told that's geometric progression. So, what's R1? What's R? R is simply G2 over G1. This implies R is equal to how much? Our G2 is 1 over 5. If you like it, G1 is 1, simply this is 1 over 5. Hence, therefore, this implies what? Absolute value of R is less than 1. 1 over 5 is less than 1. Hence, the geometric progression is convergent. Convergent geometric progression. Therefore, S, the infinite sum, is simply given by G1, 1 minus R. Because it is convergent, or else minus, or simply this 1 over 5 lies in between minus 1 and 1. So G1 is how much? G1 is 1. The common ratio is 1 minus 1 over 5. So this is 1 over, then say 5 times 1 is 5, 5 minus 1 the whole over 4. This is 4, this is 5 actually. This is 5. So this is 5 over 5 minus 1 is 4. Hence, the sum to infinity, or this, the sum, infinite sum, is nothing but what? 5 over 4. 5 over 4. 5 over 4. Always what should be reminded is if a certain geometric progression is given, if the common ratio R, or absolute value of that R is less than 1, or if R is in between minus 1 and 1, therefore we call it convergent geometric progression. Therefore we can find its infinite sum in that case, which is given by G1 over 1 minus R. This is R, therefore it's a matter of calculation. We can find the sum to infinity like this. Thank you for watching. Don't forget to subscribe to our channel. Thank you.